I'll be doing the fall challenge 2022. I haven't really done anything for the fall challenge so far because I've been busy. But let's see how far we can go today in like a short 1 to 2 hours. And let's go! Alright. Alright. So there's this wood league, bronze league, silver, gold, and legend. So the gold league is appearing today. Alright, let's see whether they can make it bronze today. So the game is called Keep Out of Keep Off the Grass. Okay, how do we do it? Control more patches than your opponent at the end of the match. Alright, robots are deployed in the field of abandoned electronics. Their purpose is to refurbish particles, self-disassembly and self-replication, but they need raw materials called recyclers. The structures will recycle everything around them into raw matter, essentially removing the patches of electronics and revealing the grass below. Oh, okay. So he just destroys the path, I guess, yeah. Players control a team, okay, to see who can control the most patches of a given scrap field. They mark patches with their team's colors. If the robots end up on the same patch, they must disassemble, okay. The robots may not cross the grass. Alright, robots that are still on the patch when it is completely recycled. So if the robots go to the recycler when the recycler happens, the robot will be destroyed. Alright, so yeah, let's see. The game is played on a grid of variable size. This patch amount of usable scrap is equal to the grass. Number of terms it will take to be completely recycled. 0 is grass. The owner, which player's team controls this patch, will be equal to -1 if the patch is neutral or grass. Any number of robots may occupy a tile, but if units end up on the same tile, they are removed 1 for 1, okay? Robots may not occupy a grass tile or share a tile with a recycler. Okay, each turn the grass... Okay, if the tile under a recycler runs out of scrap, the recycler is dismantled. Okay, so we can... Oh, so there's a level of scrap per tile, alright? Okay. Now let's just play the code one time and then we see what happens to this, alright? Each turn... Okay, so... Okay, let's just take a look how the game works. So this recycler is continuing to recycle. And then why is this tile not gone? Oh, there's scrap amount there. 3. So basically you will keep removing the recycler until... Oh, okay, I understand. Why is there an additional... Oh, you can actually buy more troops, is it, in this game? Okay. Oh, he just like crashed. Oh, so this game is about a resource building game. It's like trying to occupy more and more of the grid. He just destroyed me. Alright, just destroyed me. So yeah, alright, I sort of get the idea already. So a given tile can be subject to recycling only once per turn. Okay, if you get the recycler, you provide 1 unit of matter to the recycler's owner. Okay, what's the point of this matter? 10 units of matter can be used to build another robot. Okay, let's take a look at the boss again. So the boss, he's been running his recycler all the time. He's getting 12 matter, 13 matter, 14 matter, 15, 16. Okay, how is he able to build so many new units when he hasn't used a single... Oh, okay, so this is the piece of matter and this is... Oh, okay, I get it. Okay, this is not the piece of matter. This is basically saying this is the number of squares you have occupied. The matter is up here, so every round he gains like 2 plus 2, so this one goes up to 69. Oh, so when he's destroyed, when he destroys his unit, he will get plus 10 here. Is that the case? Okay, let's take a look again. How did he get so he has 67 here, 69, so the recycler is destroyed. Okay, this 69. Boom. Then he can build one more here. Boom. Then he can build another one. Okay, yes. So every player starts off with like 10. Okay, then how did my oh, I just increase by 10. Each turn you increase by 10. I don't know, I'm doing nothing but my recycler count is going up, so that's weird. Okay, so let's take a look why this is the case. Alright, a given tile, if a tile has adjacent recyclers from both players, oh, so you only can -1 even if there's 2. So this provides 5, this provides 4. Okay, you can move to somewhere. Alright, you can build on an adjacent tile, you can spawn a robot on a tile. Alright, build actions are computed, move and spawn are computed simultaneously. A robot cannot do both on the same turn. Units of opposing team on the same tile remove 1 for 1. Remaining robots will mark the tiles they are on, changing their owner. Recyclers affect the tiles they are on and the 4 adjacent tiles that are not grass. Tiles with size 0 are now grass. The players receive 10 base metals as well as the metal from recycling. So every turn we will have 10 metal. Okay, build actions are computed. Build is to build a new robot. Looks like we should just keep building robots. Spam the opponent, and then yeah, looks like we should. This recycler only gives you like 5. Maybe you can build 1 recycler first. How much does it cost to build a recycler? How much is a recycler? Let's see. 10 units can be used to build a robot or recycler. So actually you should build recyclers first. Destroy the tiles, and then after that occupy the remainder of your tiles. So when you build a recycler, you must make sure that your robots can escape in time, right? If not, you will end up like what happens here. Like he just built a recycler straight away, and then his units were trapped here. So that wasn't a good move, because he built the recycler straight away, and that's it. So yeah, then we should make our robots crash into the opponent. Yeah. Okay, so we can go for an annihilation strategy. We can just annihilate the opponent by crashing into them. Okay, let's just try to occupy all the squares first, and then if let's say you crash into a robot, then that's a benefit. Okay, so I'm not a very like warmonger, but if that's the strategy needed, I can always make my robots crash into the opponent. Yeah, that's not a problem. Yep, tiles owner will not change if there's no target move which are reachable. Okay, selecting a path move, shortest route. Okay, move and spawn happen simultaneously. They may be cancelled by a build action. Okay. Okay, so the build will take priority. So for 1 turn, we take weave and hide for the map, and then in my metal op metal. Okay, scrap amount is the number of times the. Okay, so we get the input for each cell, and each cell we will get scrap amount, owner, units, recycler, can spawn in range of recycler. Okay, so this means that the tile will be -1. Can spawn means can spawn, can build means you can build the recycler, and then like you have units on the cell. Okay, so we try to win this as in an easy way as possible. So okay, how do I know where my units are? There we go, units on the cell. Okay, this belongs to the owner of the cell. Okay, so what we can do is like that. We can do this. My method of method. Okay, this one is fine. Then we basically do something like my units of units. If units greater than 0, then okay, where's the cell? My units ij. Okay, so I'm thinking whether I should do it in a dictionary or doing in a list, because if you need to do it in a dictionary, then the problem is you don't really have like all the bird's eye view of the whole grid. It might be better to do this in the form of a grid. Okay. Initialization of the numpy array in the form of maybe I do numpy zeros. Shape type float. Okay, so we can just do the shape here. Okay, what else? Path. Okay, so if the path is 1, that means can go. If the path is 0, means cannot go. Alright, so what we can do is like that. My units ij, because now it's a numpy array, equals to if there's a neutral or there's yes. Yeah, we can just do something like that. So we know the number of units. So what do we need to do? We need to move, build, spawn, wait, message. Okay, so we can spawn something to an unknown tile, to own tile, build, move. Okay, so let's just do a very simple strategy. Just move own units to opponent's units. To maybe maybe we just pick one of to a random opponent unit. Yeah, we just do that first because I just want to see how this works. So we have some units already, and then like if scrap amount greater than 0, then what we can do is this one is part of the path. Yeah. So we can just put path is as okay. So we can also okay, now I need to implement like a depth search here, like some form of depth or breadth search. Wonder how big x and y would be for how big would the width of this be. Yeah, I find that there's too much information for wood league. Like honestly, this feels like a bronze league level of description. Probably for wood league, what they should have done is they should just put one robot and probably just like remove the recycler part. Okay, so this recycler one should be added later. That means this challenge there's actually more things to do in the bronze league, because like this wood league feels like the old bronze league already based on the past challenges I've done. Yeah, there's a bit too much information, and honestly if you haven't done the AI coding challenge, this is quite daunting for beginners. So yeah, my feedback for the coding game stuff will be like tone down a bit on the wood league, make it easier. Yeah, so okay, let's take a look at how to do this. So I'm just going to do a very simple thing. I'm just going to move my own units to a random opponent unit. But before that, if we can spawn, okay, spawn a unit on the, okay, we can spawn it on basically the tiles you control, right? So how do I know whether I can spawn there? So let's see. How do I know whether I can spawn there? Move and spawn. Construct a number of robots given on the given tile a player controls. Okay, how do I know where I control? Okay. Alright. Owner, which player's team control this patch? Okay, so I guess if my unit is already there, okay, then I will already know the number of units and I already know who has the patch already. So maybe I don't even need this. I can just use this. Okay, and then what happens is like that. Because no one will own grass, right? Grass is neutral, so we already know who owns a certain path. So like you can just put my units equals to this. Maybe what I can do is, in order to know whether or not like I own a unit, I can just use this my units thing to find out. Instead of mp.zeros, I can do mp.fill. I fill them with -1. So if it's like 0, I already know that. Okay, so numpy fill. Numpy fill is you can fill an array with something. So okay, maybe numpy.full, because then you initialize it with that fixed value. So initialize with a size with a certain value like that. So you can do numpy.full like that, and then initialize it with -1. So you really know like that if it's a 0 or 1 is your, so anything in my units you can spawn. Okay, you can spawn. Okay, if we can spawn, we spawn it. Okay, so what I want to do, if we can spawn unit on an unoccupied square if possible. So we just need to find whether or not there's like any unoccupied squares here. So maybe, you know, maybe we don't need to do this because I still want to know which squares are unoccupied. So maybe what I can do is like that. I can still keep the zeros. Okay, but what I want to do is I want to move a unit to an unoccupied square if possible. Spawn a unit on own unoccupied square if possible. Okay, move own units to other. Is there a benefit for me occupying more squares? Is there a benefit for me occupying more squares? So this one I put some form of depth first search. Maybe breadth first search. Breadth first search. From one point to another point. Yeah. We'll settle this breadth first search later. Okay. Define BFS point X point Y and with the map. Okay, with the grid. Yeah. Okay, so this one is to be implemented. Okay. Alright, let's just do this first. Okay, so what I need to do is I need to know what are the units that I can spawn on, because I want to spawn as many as possible on the unoccupied squares. Okay, so maybe we only spawn a unit when there's an unoccupied square, so we can maximize the number of units we have. Spawn a unit on an unoccupied square if possible, and then like so maybe we only set the spawning to be when there's an unoccupied square. If we can, then after that, next is, I'm not going to build a recycler at all, so like we can just move units to the other side. Yeah, I'm thinking maybe one strategy will be to keep recycling the, like after you have moved away from the paths that you don't want, you can put a recycler there and you can reap the benefits of that recycler by like, what do you call that, by making the grid smaller for both sides. Yeah, or you can just put the recycler near the opponent's territory and then try to recycle him into one corner. Yeah, that may be the meta strategy. Like if you recycle your opponent into one corner, you will definitely get more tiles than the opponent, right? Because like, yeah, but the problem is that probably won't happen. Yeah, so we see how it goes first. We build a unit on an unoccupied square and then move units to and move units to one of the opponents. Yeah, we basically kamikaze ourselves to the opponents. So let's try it. Alright, if we can spawn a unit on own unoccupied square if possible. So we have like my unoccupied squares. Yep. And then we also have opponents unoccupied squares. Okay, I mean we just need to be fair to both sides. Okay, so we have my unoccupied squares here. So here, units is 0 and my so maybe what I'll do is I'll just put this as a list instead of that. So we can append this. If units is 0, opponents unoccupied squares. We can just do something like that. Alright, so that's we get all the unoccupied squares. So basically, if okay, so we have the scrap amount also, right? So how do we know who has my meta and odd meta? If my meta greater than 10. Okay, while my meta, you spawn as much as possible. Okay, my meta minus equals to 10. Hi Venom, what do you type? I want to offer promotion. Oh no, this one is probably a bot. Yeah. Alright, let's continue. Yep. Wow, my meta greater than 10, my meta minus equals to 10. Okay, this basically spawns a unit on unoccupied square, right? So my unoccupied squares dot append the no, actually what we should do is we should have a list of actions now. So you have these actions all over here that we are going to separate by this. So, okay, so what we do is action this dot append. Build, no, not build. Move spawn, yeah. Spawn amount. Okay, the amount we just put as 1 first. Okay, plus okay, we can just do a F string here actually. Yeah, we just spawn 1 first. Later we see how it works. Okay, we just basically spawn a unit on each unoccupied square and then we basically move our units to one of the opponents or to to the nearest opponent. Yeah, so actually in order to do that, it can be quite tricky because we need to do some form of pathfinding. Yeah, so what we can do is we can just move our units to one of opponent's unoccupied squares, or move our units to, because we really should spawn our units on our own unoccupied square, we move our units to our opponent's unoccupied squares. So what we'll do is we'll just take one of the squares and then we just move towards there, or I don't know, I mean we can just think of moving them somewhere. Yeah. So like we just move to one of the opponents. Yeah, so maybe op units over here. So I wonder if I should do it as a numpy array or I should do it as a list like that. And I can just read off the list. Because if not, I will have to reference this here to get the position. Yeah, maybe I'll do it as a list. Maybe I do as units ij, so I know where has the most units. Okay, then over here ops unit. Okay, that would work. What's there's this squiggly line here though? Ops unit dot append units ij. Okay. Okay, I think that sort of works, right? Yeah. That sort of works right now. Yeah, so let's just see what's, I think this is correct. Can't access because it's a dictionary. Okay, that doesn't make sense. Okay, I mean it should be okay already. Later we just check it out. Okay, so we have a list of actions. Over here, what we need to do is we need to print action list dot print action list like that. Yeah, we can do this very cool thing. You can just print the whole thing because you just need to separate this with what do you call that? You need to separate this with semicolon. Yeah, like that. Yeah. If length action list, actually we don't need to do that. We will always be moving. We should never do nothing. Yeah, for this program. So move our units to one of the opponents. So what we can do is okay, can I move something that I just built, or can I only build? So what's the priority first? Build first, then move and spawn actions are computed simultaneously. So if you build, you spawn, you cannot move. Alright. Okay. Move our units to one of the opponents. Okay, so we kind of need to, like, for all the units that we have so far in my units, for unit in my units, we sort of just want to make it move towards the opponent. Yeah, so what do we do is, okay, so the to do is to find out which opponent is nearer. Okay, we just move towards the nearest opponent. So our strategy is to build more units and crash our units onto the opponent. And let's take a look. Find out which of the opponent is nearer. Okay, this one we do it as a to-do because we also need to do this breakfast search here. So what we just do is we just put a move here. Move. Amount from to. Yeah, so we just move everything. So okay, in the unit here we have units ij. I kind of want to prioritize such that I kind of move the most units first, then the second most units, and so on. So okay, maybe that doesn't matter now. So let's just do first. Yeah, always start simple, then we think of the harder one later. So move amounts. So we can just basically type in like amount xy, right? Okay, we can move the amount. Okay, and we can move from x, y, up x and up y. Maybe what we can do is we can just like randomly pick one unit here. Yeah. I know it will look weird, but okay, I know it will look weird, but we can just randomly choose one using this mp.random.choice. Okay, we can pick an array here, and then like we can choose one of them. We can sample one of them from there. Do you win if the opponent is gone? Yeah, the game doesn't end if you destroy your opponent. You need to occupy more patches than your opponent at the end of the match. So what could be done is I could just instead of going to the opponent, I could just go to one of the opponent's occupied squares. Yeah, so we could just do like random one of the okay, later we need to sort of like find out where is nearer. Okay, let's see whether this works. I don't know, I just spent half an hour. Okay, let's see whether this kind of works. Oh, we haven't index 7 is out of bounds for axis and line 38. Oh, because this is in terms of height and width, but over here I should do height and width here. Yeah, we should do this. Let's try again. So the move, all this looks okay already. Okay, what's wrong now? 49, this must be one dimensional. So what do I get when I return mp.random.choice? This one. Yeah, because if the opponent is on it, it's also considered occupied. So yeah, let's just do this, something like that. Yeah. Okay, this must be one dimensional. So this up unoccupied squares. Something like that. Is this how we go to the error file? Standard error. Sys.standard error. Okay, let's see whether this works. So this is the opponent's unoccupied squares, which is quite big. 0, 0, 0, 1, 0, 2. Oh wow, okay, it's more than I expected. Like, I thought there would be fewer of this. It appears to be appending everything actually. Oh no. It appears to be appending everything in my opinion. Like over here, opponent unoccupied squares is like everything. That's very weird. Really very weird. Let's try again. This opponent unoccupied square shouldn't be that long of a list. Yeah, this is very weird. That is so long. Like it occupies every single square of the game. Like 6 to 6, 13. Yeah, it occupies everything, which is very weird because that shouldn't be the case. Yeah. Now the grid is randomly generated. You can see that like every single square starts differently. Like this is over here. Alright, so how do we do this? Like, why is there this error here? Value is one dimensional. 48 random.choice. Opponents unoccupied squares. Okay, must be one dimensional. Maybe I did it wrongly. I see a 1D like array. Okay, so that's the problem. So we can do mp.random.randin. Okay, length. That's fine, right? mp.random.randin. It should give us the right thing already. Okay. And we just reference the index like that. Okay. So we will spawn on all the unoccupied squares we have, and then we'll move to the opponent. Let's see how well this code runs. Okay. Okay, I'm not spawning enough because all this over here I'm not spawning. Somehow they're not moving. Yeah. I expect actually all of them to move, but somehow they're not moving. Unless I specify them wrongly. Where's my move? The recycler is actually quite important because the recycler gives you more scrap metal. So I move from 2x to y. From x from y. In this case x is... What's my x? X is the width or the height. Oh, okay, I know why. This is 3, 0 and this is 1, 2. So I did wrongly already. So what I should do is I should append them because I store them y first. Now we should just reverse y and x like that. Yeah, that should do the trick for this. Hi Dahin Ninja. Yeah, I'm still very new to this challenge. It's the first. Oh, I won! Wow. Okay. Oh, okay. Right. What's wrong with this? Yeah, I think I need to build some like recyclers. If not, there will be problems. Okay, right now something's happening to this. It's not moving as fast as I expected it to. Okay, I think it might be the printing of this. Okay, I mean if you look here you can see that I actually should be spawning more, but then I'm not spawning. Okay, so maybe because I'm spawning the wrong location. Okay, let's try again, see whether this kind of works. Oh, actually I'm spawning the correct location. So that means there's not enough unoccupied squares by me in that case. Isn't all this all occupied by me already? Okay, so I spawn here, alright. Okay, I don't want to spawn on my units itself, so let's try to spawn on like spawn on squares that don't have my tiles. Let's try again. I want to have like only one of each tile. One tank per tile if possible. Wow, what a lag. Is there something happening now? Like gold leak or something? Yeah. Okay. In the end I spawn and then I end up going there. Narrowly won. This is actually not a good sign. It means that this is not very efficient. Yeah, I think gold opens today, right? Yeah. The problem is I haven't really been like following this. Okay, I think I need to build a recycler because you see like over here, like going into an opponent's unoccupied square is not going to cut it. Okay. Like we may have problems here because the opponent is having a lot more. It's only because the opponent is not doing well. He's just spawning at some weird location. Yeah, but we are not doing very well either. Like we need to focus on covering more area, especially covering the areas that the opponent is. Let's try again. Yeah. I mean, so far it looks like it can win the boss pretty well. Let's take a look at what other people are doing, and we can get some inspiration. Okay, so looks like this failed. I think there needs to be some form of like I cannot just keep crashing into them. I need to do some recycling because over here I lost in the battle game because I did not have enough recyclers. So what I should do is maybe I should just do a recycler if I can do a recycler. Otherwise I spawn. Yeah, maybe I should just like recycle every round if possible. Okay, so okay, so we need to know like whether or not like can build here. Like can build means so I definitely need to build a recycler. I think the recycler is is a is a strategy that you need to do. If not, you will lose out in parts. Then you cannot win the numbers game. Because when both players crash, they actually like respawn again. So see, I lost the numbers game already because I didn't build the recycler. This is a complicated game actually. Yeah, like right now I'm just doing a very simple rule, and I can see that this game is very complicated already. I think every round should build some form of recycler somewhere in the center. So maybe not every round, but like if I can get past to the center here, I should build a recycler in the center. So okay, let's see the can build part. Yeah, actually I'm more of a fan of building the recycler like at your base so you can like get more already. So maybe every move you can build like one recycler just as a default. Okay, what should I build for this? I should do build x, y. Okay. Okay, so we just have a my recycler squares. So my recycler squares will be here. So how do we know whether we should build that? So like we can go to can build if you're allowed to build a recycler on this turn. If can build okay, so we have a recycler squares like that. Okay, my recycler squares. Okay, so it builds the recycler already. Oh, in the end I got killed myself because I built too many recyclers. In the end I have 58. Actually I have a lot of the recycler strategy worked, but I trapped myself. So this is something that shouldn't be done. I mean, like, I think there needs to be a smart way to build recyclers such that your units can still move. Yeah, you see over here is like a bit overwhelming. I think one thing that I want to set for the recycler is that it must not be beside my own units. So like if my units are like over there, I shouldn't I should make sure my units are not in range of recycler because we don't want to trap ourselves. So like this, here is IAJ, right? For adjacent cell in, there we can just put like a few of them, I plus J, I plus 1. In fact, we also don't want to build on the basically can build, but if the unit is there, we don't want to build. So if the cells are like that, IJ, I plus 1 J, I minus 1 J, I J minus 1. Oh, it's so hard to get out of Wood League for this challenge. Usually Wood League is like done in 10 minutes for me. This is the first time I'm taking so long for Wood League. So okay, or we can just do like this adjacent cell in this. If okay, adjacent cell is in my recycler squares. Okay, then what we do is we just remove it. Remove. Okay, let's try doing this. So we don't want to let our recycler be in the adjacent cells of any of our units. So I haven't even done any pathfinding yet. I'm just making sure that if we were to build a recycler, it must not be in the path of any unit. Oh, this is wrong already, right? I shouldn't build here because like it's in range of all my units. Yeah, I think we need to sort of see what let's take a look at what my recycler squares are. Zero, 4 and 1, 4 here, and here. Yeah, I guess it makes sense. Oh, I trapped myself. I think we also need to make sure that the recycler is not near any other recycler. Yeah, we don't want to put like two recyclers at the same place. So okay, the problem with building a recycler like that in your own area is that you remove away like tiles over here that you could build. So maybe we should only build recyclers like the middle. I don't know, like to cut them off, cut the opponent off. Recycle in the middle strategy. I don't know, would that be better? Yeah, but this one will definitely give you like more in the short term. Okay, let's just try to make sure that the recycler don't clash with each other first. Each turn, adjacent cells are used for recycling, reducing their scrap amount, providing 1 unit of metal to the recycler's owner. Meaning his scrap amount can go down by 1. And I think what I want to do is I want to make sure that wherever you recycle, you can have 5. Okay, I think that one maybe we can check later, but Okay, let's try that. Okay, so we basically make sure that there's no other recyclers in the vicinity. Oh no. When two units get attacked, the blue, oh, okay, so it means the recycler has removed away the path. So you can see in the end I have a lot more units, but my units are all like trapped. Yeah, so this is the problem with the recycler strategy. Like you have a lot more units at the start, but later on you don't have enough tiles because like I just spam the recyclers here. Yeah, I think I know how to do it already. So basically, we just basically don't do any recycling until first contact. Then after that, we just spam the recyclers, I guess. Yeah. If the tile is being eaten up by the recycler, okay, how about this? If there are opponent tiles there, I'll recycle them. If not, I won't. Because you see over here, I'm eating up my own tiles. Only when I go to an opponent's tile, then I build a recycler there. Yeah. So maybe we could do that. Like you build the recycler only at the opponent's tile so that we can just recycle away his tile rather than going over it. Yeah, maybe we can just do that. Instead of doing this here, okay, we don't need to do this. Okay, we can just make sure that like uh like in the opponent's units, like over here we have the opponent unoccupied squares, right? In the opponent unoccupied squares, okay, as long as we can build our recycler beside it, we can just go ahead and build one of them. So I want the recycler to like kind of affect the opponent as much as possible. You see over here, it's actually quite good. Yeah, but I want the recycler such that whenever I build there, it kind of affects like it should be okay. Where's my unoccupied square? Yeah, my unoccupied squares is here. I want it to recycle the opponent squares. So let's see how we can do it. If we can spawn, okay, so this is blah blah. So yeah, a bit too many recycles already. So it's like I have a hell of troops right now, but then I'm not able to like win. So let's see how to do it. Oh, look at that. Oh, there's 13 days left to this challenge. Wow. A lot of time for people to improve. Usually it's only like 10 days for the whole challenge. Yeah, I kind of really want to recycle the opponent's land. Okay, what I should do is like that. For each in my recycler square. Okay, we just make sure that opponent's squares occupy at least 3 of them. Is it realistic? Oh, this square. Yeah, because we are kind of destroying ourselves, but we want to make sure that we destroy our opponent as well. So we make sure that the opponent square occupies 1 of it. So if this in my recycler squares, we should remove this adjacent cell. Okay, if this is like that, we should remove it. And then what we'll do is we'll just if this adjacent cell is in opponent's unoccupied squares, I think we just need to make sure that it eats into 2 of the opponent's squares. If the opponent count is greater or equals to 2, then we can build a recycler there. Yep. Then we don't limit the number of recyclers, we can have more than 1. Or actually we just build 1 per turn. I think don't need to build too many. This one is like that. And just break. And then we can build like JI. Yeah, let's try doing this. So we built the recycler only at the opponent's area. Now let's see what happens. Oh, why am I still building there? Yeah, okay. Alright, something is wrong here, you see? I shouldn't be... I'm blue, right? I shouldn't be building so much recyclers when it's not in any of the opponent's squares. See over here? So the problem is the unoccupied squares, like... Is everyone, is it? Yeah, somehow the unoccupied squares are all the squares. So it's very funny that that's the case. I mean, this is the case, and then it's like that. This shouldn't take into account all the squares because like the owner is not going to be -1 all the time. Oh, well, equal -1 if the patch is neutral or grass. Okay, so this should be 0. Oh, no wonder I'm not going to the opponent. I'm like, okay, this one up units dot append. No, op units is not a dick. Oh, okay. I see. Okay, looks promising now. So I will only build the recycler when I go to the opponent's side. Oh, so all this while I've been not heading to the opponent in that case. Wow. No wonder I've been like not. Yeah, there we go. We prioritize building recyclers only when we see 2 or more of the opponent's patches that we build there to eat up his patch. Because when the recycler is built, his patch will be eaten up already. So that's the baseline strategy. And then like right now I'm just trying to head towards the opponent. I never even try to maximize the squares nearby. So that one will be done later with some flood fill method to like maximize the area. But right now I think this is sort of working. Yeah, I'll probably try to do some like flood fill the next time I stream this. Yeah, it looks like it's this simple way. Okay, basically I just need to make sure I build the recycler only when there's opponent has occupied 2 of the squares, so the recycler can actually help to like sort of destroy his squares. Yeah, and then I just keep heading to the opponent to like destroy him. Okay, so alright, let's test it out in arena and see how we fare. I mean, oh, okay, doing well. Okay, everyone is doing well. We might be able to break out of Wood League finally. Yeah. Oh gosh, this is so difficult. Yeah, it's like I had to do for 1 hour of this. Okay, so next up will be to find a better way to head towards the opponent by making sure that you head towards something that is nearer. This guy built a lot of recyclers also. Is it recyclers actually kill your area? It's very promising. See, everything. I'm winning all the games right now. This is Wood 1 League, which means that after this will be the Bronze League already, and then we can see like what will be the additions that Bronze League brings to us, and then we'll probably like code Bronze League on another stream session. Yeah, I mean, given that this is 13 days long, I'm in no rush to like rush out the code, but I would like to at least get myself into silver or gold. I think it's possible. I haven't even coded the flood field yet. Okay, we have lost 1 game here. Oh wow, what happened? Oh, he keep building recyclers. You see, he spam recyclers, and then he basically spam himself out. Yeah, but because he occupied, so actually it's by luck. Yeah, I mean, he built more recyclers than me, but he like sort of spam himself out of the game. Yeah. This is BBSSO. Yeah. I lost here also. But overall, this strategy seems to be doing well. Yeah, and bear in mind, I'm not even like. Oh, actually, this guy is doing well. Actually, he didn't even build anything. Yet he's doing so well. Did he do some form of pathfinding? Or it's just luck? Because I kind of destroyed my own path. I didn't care about the path, but yeah. I mean, looks like I can win this. Yeah, looks like I can win this. Like over multiple games, I'm still winning them. You see, I'm playing against them in so many different games. I turn in. Okay, I didn't even do the pathfinding. Yeah, but it looks like I will be able to beat the boss. Wow, wood one leg is so difficult this time around. Yeah, it's really very difficult this time around. I didn't expect it to be so hard to code because usually I will pass wood leg in 10 to 15 minutes. This one took me 1 hour plus. I think this means this is probably it already. I think I'll probably pass the leg. Yeah, this is probably it. Right. What I should do now is I should do some form of I'm pretty sure I will need to do some form of breakfast search at some point. Okay, so I might as well do it now. See, rank 1. Oh, okay. But I'm quite excited to see what what Bronze League has. So let's take a look at what Bronze League has first before we do the code for the next one, which will probably be in the next stream because it's already been 1 hour plus. Alright, let's see what Bronze League has to bring before we end the stream today. Oh, Bronze League. Okay. Is there nothing different over it? Oh, there's nothing that has changed in the Wood League also. The Wood League is the full game already, is it? Oh, okay, they changed this already. So seems like oh, interesting. I wonder if I would win the boss for this. Yeah, seems like there's no this is very weird. Like also they already give you the whole game at the beginning. Interesting. Oh, I won the boss. My rudimentary code has won the boss. I'm just like doing, and look at this. I'm not even doing any pathfinding. Yeah, it looks like I may even go to Silver League with this rudimentary code without any pathfinding. Oh wow. Okay, but it's too hard a difficulty gap for wood. I feel like they shouldn't have done that. Like it feels a bit daunting for first time players to have so many rules at the wood league. Okay, it looks like I can win the boss pretty reliably, right? Yeah, I mean just this simple code of this is the secret sauce that I have right now is to just build the recycler in at least two of the to make sure that the opponent occupies at least two of the neighboring squares. Then I build the recycler. And then what I do is I just kamikaze into the opponent's one of the unoccupied squares here. Yeah, so this already works out pretty well. I'm not even, you look at this, I'm not even occupying more squares, you see. Yeah, I'm just focusing on just whacking the opponent. It's a very it's a very rudimentary strategy, but like the idea is to like limit it at the source, I guess. Yeah, and I didn't use any pathfinding. I just basically just whack any random like opponent square. Like my code is just very simple. It's like you just spawn the recycler on the cell that contains at least two opponent squares, like up, down, left, right. So in the hopes that the recycler will destroy those two squares. And then like I just hit directly straight towards the opponent. Okay, let's just try one more. Maybe I should code out the depth first, the breadth first search, because I think this will be helpful for the future leagues. Oh, I'm still winning the bronze boss. Okay, all's good. Oh, this this nonsense code that I wrote is good enough. Okay, is it good enough? May not be. It's like I'm losing also. So let's take a look at this guy, whoever this guy is. Okay, Occitante Freelancer. So I lost this one. Oh, he trapped me. He trapped me. Look at that. He has so many units. And I'm not able to get out of this area. So actually I trapped myself. Like, you know, because it's me that built the recyclers actually. Like, over here, I could have gone into his area, but I chose to build recyclers there, and then like, I won the mini game, but I lost the outside. So I gave him this big unit here. So I guess if you could like, I see his units occupy all the squares first. Yeah, his is occupying squares thing, but mine is a kamikaze thing. Yeah, so if each unit can go to the nearest red unit, I would occupy all the squares as well, as long as the opponent. Yeah, so I need to build some form of pathfinding. Yeah, so right now I think, yeah, sorry, Ninja, you said something. They have code for unit warps jumps in the referee, but they don't use it in this challenge. Oh, what's the use of the unit warp though? Because like, is it just for debugging purposes, or is it for like they wanted to add it as more rules, but they decided against it in the end? Okay, looks like I can win the boss rather reliably, but because of the fact I'm like losing a lot of other players, I'm not able to progress to the next league. And I think the main reason is really because like I simply just, I think this last part needs to change. I simply just randomly move towards an opponent's unoccupied square. But what I should do is I should just do breadth search. As long as the unit, okay, can go to a particular like square already, that is the based on the opponent. Okay, so over here to do move units via search to the nearest unoccupied or opponent's square. So like we actually just kamikaze to the opponent. Yeah, I'm more in favor of that. Like, just whack the opponent's unit straight. I mean, I'm not even bothering the neutral squares here. I'm just going straight to the opponent's squares. Yeah, so let's see how it goes. Yeah, so right, move our units to the opponent's unoccupied squares, to the nearest opponent unit or square. Yeah, so it looks like I have gotten my code stuck here. Okay, it looks like it's going to be stuck in Bronze League. Okay, although I beat the boss very reliably, as you can see, like I'm beating the boss every single time I run it, because I think my code counters the boss quite well. Yeah, but I'm not able to like plan out the map. I'm not able to do the broad picture kind of planning, because I did not code for it in my code intentionally, because I just want to get out of Wood League. So in order to do this game more successfully, when you build your recycler, more than just making sure that there's more opponent squares there, you need to strategize cutting off the map for your opponent. So the more you can cut off the opponent's map, okay, and of course you need to make sure when you cut off the map, you have a bigger slice of the map. Yeah, if you can do that, you can use the recycler to strategize cutting the map and restricting the opponent's influence. The opponent might have many units at one small corner of the map, but you will win the game because you occupy the rest of the map. So the cutting the map strategy works, but it's very risky because the opponent can actually find ways to bypass and go to your side, yeah, while you are building the recycler. So yeah, I mean, this is the, like you see over here, unintentionally I cut him off already. So he got this small island for himself. Yeah, I guess one way I can improve on it without thinking too much about broad picture, because I think that broad picture thinking maybe is a legend level kind of thinking. I think the first improvement is, you see this unit over here. Okay, we need to know like where are the regions that are not currently, like over here. Move our units randomly towards the opponent's occupied squares or neutral squares. So maybe like we kind of need to have neutral squares here. So like maybe neutral squares. Yeah, as much as I don't like, I think occupying the neutral square might be also a very useful strategy, because it is quite important to spread out. So of course we prioritize hitting the opponent first only if, in this kind of case where we are isolated in one owl, then my focus will be on occupying all the squares possible. So okay, so let's see, how do I add this in the code? We can add this like here. Yeah, we can add this here. Else, I mean, I know this is going to be -1, but I just want to make sure. We can just add in the neutral squares here. We can just add in the neutral squares here. Yep, something like that. Oops, we add the neutral squares here. Alright, so here we need to change to the nearest opponent unit. Okay, so what we will do here is this. Okay, so we need to like move. I'll just put this here. So we maybe just, okay, because I want to move towards the nearest opponent unit and there will just breadth search there, or I could specify the next square to like concretely tell the move. But I think right now I can just specify the end goal and let the breadth search do its thing. Yeah, because the end goal will be like the goal that I'm interested in. So yeah, we can just do that. This one can take away. So it's no longer point X to point Y. Okay, this one maybe we can implement later. Find the nearest square which coincides with target squares. So define find square. Okay, so we have initial points and we have target points, and then we have the grid. So basically, like with this target points, and the grid is basically going to be like my unoccupied squares. Yeah, maybe the target points will be like, it's actually path. It's actually path. Yeah, so yeah, we can actually just use this path as the way to find out whether or not you can pass by that square or not. So your grid, this one is actually a path. So like we can have like this, my squares equals to this. So we also need to know like how many times we should do this iteration, because we do have okay, it's quite simple actually. In order to do the iteration, it's like you just keep finding out your initial points until like you expand out fully and you still haven't covered the whole grid. You can just know that you are gone already. Yeah, you can already do that. Yeah, boom. Okay, so in the end, I think my final score is about 190. Okay, although I can win all the way this bronze boss all the way. Okay, I'm unable to win the league because in the league is more than just winning the boss. You also need to win the other competitors and have a higher elo rating compared the other competitors with respect to the boss elo's rating. So you kind of need to win like almost 80 to 90% of the league in order to progress to the next level. And it's not a problem. Yeah, I think getting silver is not difficult after implementing this thing here. Okay, so let's try to implement this. So we find the square, initial point, and target points. Okay, so we have like, we can have grid called history. We can have points. We just quite points equals to initial points. Yeah, like that. Okay, so wow. Okay, points. Okay, so we keep looping until we run out of points, until we run out of possible starting positions. Okay, so what we do is like that. We will just pop the point. Okay, so it's like this. How do you do it? Next point stop pop, something like that. Yeah, and then we just make sure that like in this grid itself. Okay, so the next point is I and J, right? So like you can just do I and J like that, or X and Y, or whatever works. Yeah, then if the grid is 1, if it's passable, so grid ij. Also, we just check if the next part of the map is accessible. So we can do that same code that we did earlier on here, like this one, something like that. We can just put it here for adjacent cell in the next part. Okay, but the adjacent cell don't take itself. Yeah, like that. Yep. If grid adjacent cell like that. Yeah, if grid, oh no, actually like that. If grid adjacent cell is 1, or actually we don't even need to do something like this here. Okay, this one will be faster to reference, so maybe we keep it like that. And okay, so we need to append this to history. Okay, okay, then we do points dot append. Okay, so we are done here. Okay, and then we just need to check like if any okay, actually before we even append, we can just check if any of the next cell hit the target points, return that. Okay, so if adjacent cell in target points, we can just return the adjacent cell straight away. Okay, if we finish all this without this, we can just return none. Okay, so it means that we don't have a cell that is in our target. Okay, so over here right now we can do this. Okay, instead of doing a random thing here, we can just like find square. Okay, we can do the find square here. So we can let's put this away first. Cell equals to find square. Okay, what did I put here? Initial point. So the initial point here will be x, y. Okay, and then the next thing is target points, and the target points here is the opponent's units. So this will be opponent unoccupied squares. Opponent unoccupied squares is this one here. So Yeah, we can do this opponent unoccupied squares, and then we can pass in the grid, which is the path. Okay, because the path here will tell you whether or not you can traverse that. Okay, will you destroy the path before or after? That's the thing. So over here, I'm only taking account the next time step. I don't take account whether by the time you reach there, the path will be destroyed or not. So this one will need to be, you need to calculate this for better AI. Maybe that can be done for Go League. Like you need to make sure that when you reach there, the path will still be existing because the path can be destroyed when you reach there. Yeah, so you have a path. I just want to see whether like the path itself, would the path be destroyed first or will you go first? Yeah, you move first. So that means if the scrap metal is more than one, yeah, if the scrap metal is more than one, yeah, thanks that ninja. If basically the scrap metal is more than 0 for that turn, you can definitely traverse that tile. Yeah, but for more long range and more future planning, you probably would want to take into account whether or not that tile has a recycler, which is this thing here. Like, because this means that that tile can last you X number of turns, where X refers to the amount of scrap metal left. So you can take that into account. If your path length to there is more than X, then there will be no path by the time you reach there. So maybe I should do that. Maybe I should do that now. I mean, like, no point going there and then get destroyed, right? So maybe I can already take into account that. Okay, but let's do this first. Okay, I think modification will be easy. If cell is none, okay, then we can find square. Find square of a neutral tile. So if we cannot go to that opponent, we will go to the neutral. So where is my neutral tile? Okay, maybe what I will do is instead of having this path here being 1, I just make this equal to the scrap amount. Yeah, so I can actually already implement whatever logic I wanted here. So okay, here instead of points, I put new points. So yeah, we can do a double loop actually, so that we can actually account. We can account for the number of cycles over here. So like we can have like path length variable here. So like you must be more than 1 for it to work out. Okay, so greater than path length. Yeah, and then we increment the path length every time we, yep, so basically look for current position. So find next position from current position. Okay, and then after we add into this new thing called new points, okay, because then we will finish up this points here, and then after that, when this is done, we now do the next set of points. Yeah, and then over here we can look back here again. Yeah, so this kind of will work, I think. Yeah, but somehow this is, no, this is not known. Yeah, okay, so I think I've done the part where you cater or not into. Okay, so there's a problem here. Okay, the problem is that you don't know whether or not, like, there is, like, you don't really know whether or not there's a recycler there, so you cannot just keep doing this. So there's a slight problem here. We need to, like, make sure that this cell itself has a recycler. Yeah, okay, I think what I'll do is I'll just because I need to use the toilet for a while. I'll just go out for a while and I'll be back shortly, and then we work on this code. Okay, see you in a bit. Yeah. Okay, I'm back. So now let's try to build this logic here. So we only destroy this path length thing only when like that cell itself contains, so we need to have one more. So we need to have like an adjacent recycler squares. So yeah. Blah 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 blah. Yeah, I prefer to do a lookup directly because that will be faster than doing a search in the loop. Yeah, like something like this needs to be done because you need to search for all the target points, but if you can just like do an array kind of lookup, you don't need to do that. Yeah, so okay, let's just make sure this part is done first, and then like if this is path length and adjacent recycler, okay. Okay, as long as this is done. Okay, so okay, let me just put the comments here. Make sure the Excel has not been explored before, and it is traversable, and it is still traversable even after being recycled. Okay, so this should do it. New points is not shown, just like that. Oops. New points, yeah, like that. Yeah. So we find square of, we still need to append this half and adjacent recycler. Did I call it adjacent recycler? Yeah. Adjacent recycler squares. Okay. Move units via search to the nearest neutral square. Here is neutral squares, half adjacent recycler squares. Okay, and then like if cell is not none, okay, so we can put cell 0, cell 1. Okay, because this is xy, but here's yx, so it should be 1 0. Yeah. Oh, wrong. Still yx, still xy, and then this op x, op y. Instead of doing this, I should do cell 1 and cell 2. So we need to switch it. Yeah. Cell 1 and cell 0. It's very funny why CodinGame decides to like put the squares like this, like 7 3. This one usually like normally we call it 1 0, 2 0, 3 0, but CodinGame likes to do it the other way around. They always put the y-axis as the second variable, which is very irritating sometimes. Okay, let's take a look. Okay, so I lost now because of some issue. Index outbounds on line 33. So this adjacent cell here cannot be put like that. So maybe what we can do is like this xy, or maybe you can just put ab equals to adjacent cell. X is always first. Yeah, x is always first, correct. No, but in Cartesian coordinates usually we, oh yeah, actually true. Yeah, you're right. In Cartesian coordinates x is first also. It's just that in arrays we are usually very like, we always think doing rows first then columns, right? Because like that's how like an array is initialized, rows and columns. At least for grid environments that I'm used to, I always loop the rows first and I loop the columns. So it goes counter to my usual practices. Yeah, correct. You understand, yeah. So I face this issue in other CodinGame stuff as well. But it's okay, and that's not a big deal. It's not a big deal at all. You just need to remember to reverse it when you print it out. Okay. I wonder what the big boys do for this game. Yeah. Line 34 is wrong. Index error for line 34. Did I do something wrongly? Oh, oh, okay. I think I know why. Because this is x and y, right? For the cell itself. This cell is based on this height then width. Then it's correct, right? If it's height and width, this should be correct. I pen ij, right? Yeah, so yeah, it should be correct. Like this shouldn't give you an index out of bounds error for x is 0 which signs 8. Index error. Okay, I guess we will just print out. Just print out the adjacent cell. I just want to see how it looks like. We get 16, 2. Ah, okay. We need to make sure that this cell is within bounds because that was out of bounds. Size 9. I need to make sure that this doesn't exist. Like width and height, I guess these are global variables already, right? So I just need to make sure that it doesn't exceed the width and height. So I is the height. Okay, I think better don't do this. Later, there might be some problems. Let's just do all in one line. Okay. I minus 1 smaller. Yeah. I minus. Yeah, no, so over here is already affected. So index minus 13 is out of bounds for axis 1 with size. Oh, oh, oh. This is 1. Okay. Disqualified. Okay, something happened here. I didn't output anything. So did it mean that I'm not able to find the cell? Maybe let's just print this. 213. So the cell is there. So I have a unit that needs to move to 213. I printed it out. Print the action list now. Okay, so I think what I'll do is I'll not print out the recycler squares anymore. Like all this actually it came from here, right? Came from here. I think this is fine. We can remove this. Now there we go. You see, it's all here already. Is it because it's taking too long to print it out? That's why it's... Okay, now it's working. Is it moving? Oh, we can do like this limbo. What's this guy doing? This one can move actually. Why is it stuck there? Did I move wrongly? Yeah, this person is not supposed to be stuck there. I think I should start with YX here. Let's try that again because like this should be, maybe I gave it the wrong input square. There we go. Yep, okay. So he still hits for the opponent if possible. It's just bashing. So actually I don't know, I'm just like whacking the ball straight. Yeah, maybe that's not the best way to do it. I guess if someone has targeted that square already, I shouldn't go there. Yeah, see over here I can have actually people roaming. I just need one of them to target the boss. The rest can actually go somewhere else. Okay, so I think what we need to do is we need to remove the opponents from consideration after we go there, because we don't want all to go the same place. Okay, so what we do is unoccupied squares, remove cell. Remove neutral square from consideration if there is already one. If going there, because we don't want all to go in the same area. So if cell is not none, show squares dot remove cell. So we can just like remove this. Okay, let's try that. Yeah, we don't want everyone to go to the same square, right? Yeah. Okay, so that's kind of solved the trick. Okay, so there's a problem still. Okay, this guy is not moving. Or is it that he spawned there? Oh yeah, he spawned there. Okay, so I think the spawning needs to change also. Where am I spawning right now? I'm spawning on a square that is like currently unoccupied. Okay, but what I want to do is I want to spawn on a square, right? That like right now is just spawning on a random square, but we can improve. So over here, let me just put this to do improve the spawning mechanism. So we should spawn in an area that like either we want to like destroy the opponent, we should spawn next door to the opponent. I mean, we shouldn't just like randomly spawn at one of the squares. We should spawn like 2 squares that are critical. Yeah, if not it will take quite some time to like destroy the opponent. Like this part here can be improved on, but right now just going straight to the closest square, neutral or opponent square, looks promising. See, it looks promising. Like, look at that. But what is this guy doing? Looks like they're all stuck. Yeah, I think the neutral mechanism is not working. Like, they're all trying to go to the opponent, is it? But you see over here, there's so many squares for them to explore, yet they are stuck there. So maybe my neutral squares is not appended correctly. Yeah, I'm not exactly exploring the whole map. Look at that. It's stuck already. Yeah, but the recycler strategy is doing well. It's just that like this unit over here is like kind of not moving, which is rather annoying because like it should be moving. Let's figure out why. Okay, move to the closest opponent squares or neutral square. So first we move to the nearest opponent square. Okay, and if let's say the opponent is not there, we can remove it. I mean, we can remove that opponent square and then we can move on. I wonder what did I put here. Like, I actually have some move orders. No, I'm actually moving a lot of units, but okay, let's try this one. Move 9, 10, right? Nine, 10, 9, 11. Oh, I'm moving to 9, 11. Oh, I see. I see. The neutral squares also include squares that cannot be reached. Okay, so the neutral squares must be reachable. So let's try again. So in these same conditions, I want the units to explore. So right now it's stuck because it's exploring grass. Oh, I lost after I did that. Oh, is it a timeout? Oops. Okay. Maybe it's taking too long to process all this. So let's see. Like, what I want to do is I want to make sure that I don't print out anything so that I can save a bit of processing time. Okay, yeah, remove this. Yeah, let's try to do that. Yeah, remove that. Yeah, see, it's winning the boss now. So the timeout. Okay, it's not that great. Look at that. Look at that. Look at that. There's so much things it can explore. But what are my units doing? They're just moving up and down. Yeah. The boss isn't too good either. It's just like don't know what the boss is doing, but yeah, you see there's so much area to explore. It's not exploring at all. Okay. 6 blue units move here from 15-8, 15-9, 15-8. Okay, so let's take a look at this unit here, 15-9. So where did my 15-9 go to? Okay, 15-8 went to 6-7. It's going to 6-7. Why is it going to 6-7? 6-7, the nearest thing that it could go to. 6-7 is 6-7 is this one, is it? 6, 7. It's going to this one. Okay, it's going there. Okay, I see the problem already. Okay, I want it to go to 6-7 here. Okay, but that's because it's like going through this part here. It actually went through here. So rather than like returning like maybe the the square, because like pathfinding might draw you both sides, and in this case it doesn't reach there. Yeah, so this is a unique case whereby the pathfinding algorithm like wants to go both sides but fails to do so. I mean, this is a legitimate thing that it could do. So I think what should be done is we kind of need to give it the next cell. We shouldn't let the pathfinding do for us, because at this case where there's this left side and there's this right side, there are both equal number of squares. Like it's going to like, actually, is it equal number of squares? Like 15-8 is 6-7. Okay, 17-8 is 7-7. Okay, I guess it's about the same amount of squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, come back to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, it's actually more than that. Okay, this one 15-8 and 15-9. So 58 is 6-7. 59 is 12-5. Oh, 59 will go here. Yeah, so I guess I know this is one thing that can be improved on, but let's see whether it like kind of works for the rest also. Yeah, I'm thinking if let's say it can occupy the neutral squares, Like maybe it should, rather than just aiming straight for the boss, because right now I'm just going straight for the boss squares. As you can see, actually you can just form a choke point here and then he can get this whole area here. But he didn't, so the AI is not that smart. But if it was a smart AI, the AI would be able to do that. Like, you can see that a sole obsession of like going to the opponent squares has caused me to like look at the needle and miss the haystack. See, like I could have gotten all these things here. Like, why do I need to like? So maybe what I should do is I should do like both, either the neutral or the opponent. Like I can prioritize both. I don't have to purposely like go to the opponent. I can go both. So like maybe we can just call it target squares. Yeah. Okay. If it's not, then target squares dot remove this one. Then we can just remove all this already. Yeah, we have a target squares here. Okay, so now it either goes to the target squares or the opponent. Doesn't do that well now. Okay, let's revert back to the previous one. So the chasing straight to the opponent kind of works. Okay, but over here there's a problem already. Okay, let's look at this problem. 4 6 4 6 is going, sorry, 1 6 6 0 is going to 6 2. Okay, 6 1 is going to 5 0. Okay, makes sense. All right, then when we play it, what happens? Oh, I see what's the problem already. Like I make it move there, but then like after that I make it move up here again. So it's like going to two goals and it hasn't like finished its goal and it basically just like goes back again. So yeah, there's a problem here. It needs to be consistent to its goal and reach there, then be assigned a new goal. Yeah, so that's something that we need to work on. So like maybe we could have a goals setting here. I want it to continue to go. Like, yeah, this part is like not very efficient. The way that it spreads out is not efficient at all. It needs to be able to cover like. Yeah, I mean there are some goals that it needs to do, but it's not doing right now. It's like forgetting its goals. Like it goes up and down because it was assigned a previous square, but then it's being assigned another square after that. It's going up and down. This is so weird. Yeah. Yeah, it's like up and down like that. Yeah, this square is so obvious. Yeah, you just need to go over it. Yeah, you just need to go over that square. Why are you not going there? Yeah, like like the square is just here. Anyway, let's just submit this code to the arena first and just see like how well this fares already. Okay, because I already like did some script to like head towards the opponent first, followed by the neutral square. So let's see how well this is so far. Oh, not too bad. The initial runs are not too bad. Let's just see how like I lost here. This is like a time bomb. It just ticked and then the whole thing destroyed. Oh, why did I lose though? Oh, did I lose by timeout? Oh, I lost by timeout. Oh, this is bad. This is bad. Lost by timeout. How about this? He's doing the same strategy as me. He's just whacking to the opponent. Yeah, it looks like when I lost by that, I lost by timeout. That's worrying. Oh, I timeout again. But I was doing so well. Look at that. Woo! Minions. Here we go. So it looks like after a certain amount of minions, like the compute load just became too much for the agent, and it just destroyed itself. Let's see here. How did I lose again? Did I lose by timeout also? Oh wow, this stem has occupied so much. Oh, I kind of kamikaze myself here. He explores really well, this person. Against an exploration type agent, my code isn't that great. Yeah. Oh, but it's actually doing not bad. It's like 95 right now. Okay, so over here you can see that like what am I doing? I'm not even exploring. I'm just like, oh, the same thing. When he moved here, when there is given two goals and it like didn't reach any of the goals. So I don't know. Yeah, we need to do some goal setting here. Oh, but look at that. Look at that. I'm rank 14 already. So it looks like um oh, now back to 75. That was I almost went up, huh? Yeah. Okay, so I think one thing that needs to be done is I need to explore more. Yeah, definitely need to explore more because like um especially for this kind of context, it's not exactly moving anywhere. Yeah, and there's a problem also in this situation about like target squares. Yeah. It's taking too long to find this path, which cause a runtime error. I think in order to make it like fewer pieces, maybe it's needed. Maybe we need to find a way to improve this pathfinding at the bottom. If not, it will cause problems. This part here. This part here needs to be. So there's two things that need to be improved. One is the goal setting. Once he has been given a goal, it needs to like continue that goal. If not, okay. Woo. Okay, so actually, if it's just one agent, it's kind of clear cut. So maybe what I should do is yeah, I have to do this same breadth search all the time. I wonder if there's a way to like for an arbitrary start point and an arbitrary end point, whether I can calculate the path length instantly between any 2 points. Then I can just like, you know, yeah, let's see whether there's a way to do that. Dijkstra? Maybe they use Dijkstra. No, but this is starting from a current node. So I want to find like pathfinding between any set of points. All pairs shortest path. Yes. Let's try this. All pairs shortest path. Do you do that also? Because like I have a runtime error right now with I'm using some form of breadth search and it's not fast enough. Yeah. All pairs shortest path, right? Yeah. Okay, so you're right. I think we need to do a Floyd Warshall like algorithm. Get the all pairs shortest path, and so that we don't have runtime error. So yeah, this is Floyd Warshall. All right. So find alpha in the directed edge. Okay, like that. All right. For each edge UV, do this. Distance UV is WUV. For each vertex V, do this. VV is this. K from 1 to blah blah blah. Distance IJ. So you store a metric, distance table like that, and then you basically check. Okay, it's a ON cube timing. Yeah, you run it once at the beginning. Okay, for all vertexes. So here will be width times height. So it's width cube times height cube. You run it once, you store it in this distance ij, and then for this distance ij here, you can then get the distance from any node to any node, which we then can compare. Like for each node, I just need to run like for each node, I just need to check like what is the shortest distance for like the target cells, and then just choose the shortest distance. Yeah, I think this would work like much faster than the current one. Oh, I'm rank 1 already. Oh, that was fast. Yeah, but I'm still below the boss. Dahi, are you in Silver League right now? Oh, I didn't expect to be rank 1 so soon. Yeah, I thought. So it means that actually. Yeah, true. You can put the next node here in the distance. Yeah, but I don't really need the next node per se, because like the code itself can do the shortest path for me. Like, I mean, in this case, like CodinGame can get it. But of course, if we want more control, we can get the next node as well. Okay, so it looks like we should do some form of Floyd Washer, because I kind of timed out on quite a few of my submissions, like this one. Like I was winning big time. No, sorry, this is not the one. Like something like this, winning big time, and you see timeout. Yeah, you only got 1 point, but I timed out. So stuff like this can be avoided if we can do some form of more efficient algorithm to calculate this. So instead of doing this fine square, which I need to run many times, we could do something like a Floyd Warshall. Okay, so find the distance between. So I think we are not going to do breadth search for this one. It's all pairs shortest path. So this is the Floyd Warshall algorithm. Okay, so let's initialize the set of minimum distance to infinity. So we need like, what we need is a grid of like all possible points that can be traversed. Okay, and then what we will do is we will then just initialize this. Okay, grid itself yeah, I think NumPy array got ships. Yeah. Yeah, we can use this to get a height and width. You can also save the next node. I use the next node to check if the tile's in danger. from I see. So yeah, so you basically use the next node to see whether or not the next tile is in danger of being destroyed, but you only can check one next tile, right? Because you only can store one next node. So it means that the disadvantage of doing all pair shortest path is that you may not be able to do a long-term kind of planning. Yeah, you can only plan like one time step ahead. Yeah, currently my code I can check whether the thing will be destroyed because I actually check it here. But this is too slow if you have too many units, and given that the size of the grid can be quite big for this game, time is of the essence. We cannot afford to keep checking everything. Yeah, so that's very true. Yeah, I wonder if I just leave this thing here, right? Like, let's just take a look at the detailed leaderboard. Like, how much more to improve? Oh, actually, it's quite a big difference. Yeah, so probably cannot. But yeah, you can see that the code is like this guy actually came with me from Bronze League. Yeah, you can see that the code is still not the best. Let's see the full leaderboard. Like how many people are in the Silver League already? Okay, I'm at 2114. So there's currently like in Silver League there's 2,000 people. Wow. Okay. Looks like this competition is going to be tough. Yeah. Okay. So that's at least like. Okay. So let's try to improve this code. Okay, we need to first initialize the minimum distance array. Okay, actually what we can do is we can do the minimum distance array like because we get height and times width, right? Actually we don't need to do this grid.shape. Height and width are like global points already, so we can just like use height and width. So minimum distance array equals empty.zeros. Okay, height. Should I do a four-dimensional array like that? Yeah, I think maybe I should do a four-dimensional array and then like we initialize it to infinity. So initialize this to 1e9 or something like that. Or maybe don't even need 1e9, but we can just do this. For each edge, we do the weights. Okay, so the weight is actually the weight of this node is actually 0, but okay, all of the things here is actually already a vertex, and each edge is whether or not it's connected, but here we already know the edge is okay, so I'll just do like yeah, so what we should do is we should do the okay, for so we have a grid over here, so grid range height for range width. Okay, each edge initializes 1. Okay, so minimum distance array UV. Okay, so how do we find out whether it's an edge? So it's very simple. We have I and j here, the height and the width. And then first is if grid ij, which is basically going to be my scrap amount here. If this is greater than 1 or greater than 0, then this is the vertex. So this is each initialized as 1, so we need to just check now. For next array, so we can just do like I plus 1, j I minus 1, j plus 1, I j minus 1. If okay, we can just copy whatever I did here just now. If this one, you could also use BFS, Dijkstra, A star, and catch the results. Yeah, I mean, I don't have to do all pair shortest path. Yeah, catch the results of Dijkstra. Yeah, I guess so. Yeah, then you can basically, like, if you already have a path between point X and point Y, you can store that in an array. And if that array is not in use, sorry, if the array has an entry already, it's like memorization, right? If the array has an entry, then you can reference that array rather than doing the breadth search. Yeah, I think that's what you meant. Yeah, you could do that. You could use a memory array to catch the results. Yeah. I don't know, but maybe doing this all pair shortest path is like probably the easiest approach right now. Because I kind of know like what I want to do. So maybe we just do this first. Yeah, we just do like something like that. Okay, so for the minimum distance here, okay, we initialize as 1. Okay, just like over here by the algorithm, we initialize this as the weight, and the weight in this case, because it's a navigation problem, the weight is 1, so it's like that. Things you would do just because of the runtime error. Okay, after that, what we do is we loop through for this. So, yep. Oh, hi. Thanks for the follow. Yeah, who's that? Galvani. Yep. Yeah, now I'm trying to break out of Bronze League. So, I've been receiving help from Dahi Ninja here. I think Dahi Ninja probably is in Silver League already. Yeah, going to Gold League probably when Gold League release. Yeah, I just started this today. Yeah, like about 2 hours ago. So still new to this. Haven't optimized much. Alright, so now what I'm trying to do is Floyd Washout. Let's see. Minimum distance array I. Okay, this is initialized as 1. After that, we need to do this triple loop here for. Wow, okay. So I don't know whether this will bust the runtime, because like, what's height and width? 24, 12. 24 and 12. 24 times 12 times 12, 288 to the power of 3. It might be too great for Python. Yeah, I think this might lead to a runtime error just by doing Floyd Washout. Maybe caching the results will be a better way to do it. I don't know. Yeah, let's. Oh man, this number is too big. Yeah, this Floyd Washout, if you do O n cube, but because the n is 288, this is actually quite a big number. I wonder if this is about 23 million iterations. I don't think Floyd Warshall will cut it actually for Python. Yeah. Yeah. I mean, I don't even need to run this thing. I know it probably won't work. So maybe let's just scratch Floyd Warshall. Yeah, I don't think this will work for CodinGame. Yeah, let's scratch it. I mean, in order to implement it, I just need to do IJKLMN and then implement this thing here. Okay, but I think let's just delete this. I don't think this will run in time. Yeah, it's too big already. Look at this number here. Yeah, it's 23 million iterations. For 100 milliseconds, you can only have maybe about 1 million iterations for Python. Any more than that, you will probably be runtime error. Okay, so we probably need to find a way to improve this find square algorithm. So yeah, okay, I'm thinking of how to catch it. Okay, because like if all these are our targets and this is my initial point, how do I catch? Yeah, let me just run the code again, make sure it's working, make sure the code is working. Yeah, did quite a lot of changes. Need to make sure that I mean, Floyd Warshall was a decent attempt. Okay, actually this is working. Yeah. Yeah, so if we improve the spawning algorithm, we could spawn on areas like here that are like we can prioritize spawning at areas that are more isolated. That could actually like do the final push to bump you up into silver. Yeah, because my spawning algorithm, I just basically just take the first point in the unoccupied squares area, which is not that optimal. You can have some form of heuristic to tell you that these are better. You can actually spawn here and take control of the island here before you get eaten up. Yeah, that's one possibility also. Or if you could do flood fill, you can already find out that this island is bigger than this island here, and then you don't need to do anything. If not, you can focus your effort to spawn. So there's a meta level strategy that you can do in the end game when you can do like more strategizing of where to spawn. You could do that. You could do a flood fill of that area in order to see like which area is bigger, and then like how many units the opponent has. If the opponent has more units, you better spawn more and take control of the area. Yeah, but right now what I want to do is I want to solve my runtime issue, because like I submitted here. Oh, sorry, the leaderboard here. Oh no, last battles. Yeah, I'm actually losing by runtime. Is it? No, this one I lost clear cut. Who is this? This duckling. Yeah. Bailey's. Yeah. Oh, let's see what Bailey is doing. So I'm more focused on like destroying his area and attacking him. Oh, his is an exploration kind of unit. Yeah, so he kind of triggered my recyclers to activate here. Why am I not going here? Yeah, so this is the goal directedness thing I was talking about. Yeah, I need to improve. So I think one immediate thing is this goal direction finding. Okay, and the other thing is, so let me write here, to do implement a way to keep track of the previous goal, which is pretty easy. And then also next is to do implement a way to catch the previous shortest path. You need to use it. So I think this will be difficult because the previous shortest path here is to like a certain point that I want to go. But if let's say I want to do another point, and then in this case like the shortest path is somewhere else, because the targets might be different, I probably have to do the whole algorithm again. So that's a problem, because like this algorithm itself needs to do. What I can do is I can probably limit it such that I don't solve everything. I can only do it for like maybe the first like up to 50, like we cap it at 50 so that we don't like exceed the runtime. Okay, so like something happened here. Is it because of the 50 or is it because of okay, I think it's because of the map. Okay, let's remove this 50. Is this causing the problem? Like I'm losing right now for some reason. Okay, something's wrong now. Yeah. It's either something's wrong or it's just unfortunate that I lost the boss in those areas. Like now I'm losing to the boss already. I think look at that inefficiency. Okay, so we definitely need to, I think this 50 is okay. We can put this in. We definitely need to make sure that like we remember the goals. I think that's more important. See over here, these are things that could be done, and then like we still need to, I think we don't do this caching. Implement a way to keep track of the previous goal, and also implement a way to spawn smarter. Maybe spawn on islands of land with opportunity or something, with opponent squares. Yeah, we should spawn on the island and wipe out the opponent squares. Yeah, spawn closer to the opponent squares actually. Yeah, maybe we could just spawn closer to opponent squares, and that will be the best way to spawn. Like as long as you start from any of the spawn sites, and like you basically do Floyd Washer takes 11 milliseconds in C++ on CodinGame. Oh, is it? Oh, you did Floyd Washer for C++? I think Floyd Washer will have a runtime error for Python. Yeah, so maybe you have to use C++ for Floyd Washer. Because Python is a rather inefficient language for CodinGame purposes. Yeah. But it's okay, we don't need all pairs shortest path to win this challenge here. We don't need, yeah. I think we can do without it. Okay, we do the goals first. We have goals. Yeah, okay, if we do this like goals thing, we will need to know where it goes to next. Yeah, maybe we need to know like to do the next cell. The goal cell, and that's the next cell. Okay, so we need to know what's the next cell. So okay, so how do I get the next cell here? So it's very simple. What we need to do is just to store this like that. Initial points. Okay, so we can sort of store the next cell here through referencing the previous cell. But then the previous cell, you also need reference the previous cell and so on. Or we could have a history kind of thing that can like maybe parents like that. Yeah, so maybe the first time round when we go here, so parents ij, parents adjacent cell equals to this. Okay, so if parents, if ij not in parents, okay, yeah, so we only refer to like if let's say there's already a cell there, this is my next move actually. So here will be parents. Yeah, we can just do something like that. We can already store the next move. So we can return the next move like that, and we can get this next cell, and then what we can do is we can put like the goal cell of the next cell. Okay, it's the goal cell. So like we already know that in the next turn, this goes here, okay, whichever unit is in this next cell will move, and then like, and we can actually also like remove the goal for the previous cell. Yeah, actually if there's a ID for the unit, that'll be better, but there isn't, so we have to track by previous position, I guess. Yeah, so maybe what we can do is we can just like for each time round we like reset the goals. Like we have a goal cell here, and then we just make sure that we follow this goal cell here if there's any unit there. Okay, so okay, first check for any goals if there are existing goals follow them. Then assign goals. Okay, so what we'll do is like that. Okay, if goal for goal in goals, so in the goal itself, I probably need to put like the key value also, or key value in goals dot items maybe. Yeah. If key in units, okay, we kind of need to know whether there's a unit there. Oh, actually we know we don't need to do this. Assign or follow existing goals. Okay, if goal exists for xy like that, or if xy in goals, okay, then what we'll do is we'll just put like goal cell. Oh, but we kind of need to know what's an Excel, yeah. Unless we store the next cells, then we don't have to keep doing the pathfinding for this. Yeah, maybe we just store the whole path. I don't know. Yeah, that might be better actually. Yeah, we don't have memory constraints, right? Yeah, so maybe we just store the goal cells. Sorry, the next cells instead of just putting parent like that. So the parent can be this list here, and then we can just add in another one like that, like yeah, we can just put the whole path here like that. Now we start off with the first thing, which is ij. No, not ij. Adjacent cell, this one here. And then if it's in parent, then we will just add in this one plus the current move. Okay, I think that works. Yeah, so this is not exactly parent anymore. This is move history. So we just make sure that we follow the move history that we have set for ourselves. So I don't have to keep doing the search. That might actually solve the issue of not enough runtime. Yeah, we could have a move history. Okay, and then we return back the move history. And then what we'll do is we'll just like goes next cell equals to okay, we have a next cell here, so cells to go. Maybe we just call it cells to go. yeah, we call it cells to go, and then we basically just set the next cell to be this go cell. Cells to go. Next cell will be go cell. Goes. Next cell will be go cell. I don't know. Some go. Yeah, we probably need to like store the cells to go also. Yeah, like that. Okay, so over here, if go cell xy goes go cell cells to go equals to goes xy, and goes xy equals to none. Okay, we delete the go. Else, okay, if it's not in goals, we assign the goal. Okay, I'm going to put goal cell as none here first. Okay, if goal cell is not none, okay, if there is a goal, then update the goal dictionary. Okay, so we have cells to go also. Cells to go equals to none also. Okay, cells to go maybe put as nothing. Okay, here we should put like that. Yeah, okay, yeah. Alright, so that looks about right. That looks about right. So we have a goal for each of the cells. If there's already a goal, we take the goal cell and the cells to go and process it, and then we delete the goal. Okay, if there's no goal, then we okay, so over here, if there is a goal, refer to it. So maybe we don't need to cap this to 50 already. We just see how it goes. If there's a goal, refer to it. Otherwise, assign a goal. Okay, so over here it's not 2 to 2 anymore. Just move units to this. Remove this. Goal cell equals to find the square of the opponent. If no opponent, then we move to the nearest neutral space. Okay, if there's a goal, we update the goal dictionary, and then we have a next cell here that we basically assign this to the goal. Actually, we don't even need to use this as a goal cell. We can use the next cell here to make it more precise, and then we can see like how this works. I expect a runtime error because I didn't check at all. Okay, yep, I was right. 144 pop from empty list. Okay, so okay, maybe I'll just print out go cell and next cell just to see like what is being printed, what is being interpreted here. Okay, go cell and next cell is this whole list here. Okay, so the go cell is 1, 2. Okay, so I got the problem already. This next cells does not include the go cell. So over here, this next cell here, okay, it does not include. If ij in move history, over here we add ij here, right? But this does not include our adjacent cell here. And this adjacent cell here, if it's the first one, but over here, what we should do is we should add adjacent cell rather than ij. Yeah, this is the thing that needs to change. Okay, let's try again. It should print out the entire list without a runtime error now. This goes to 5.2 and the goal is 5.2, correct? Pop from empty list again, 145. Okay. Maybe I'll just put this as standard error and then we can see whether this works. Yeah, we can see whether this works. Okay, so still pop from empty list. Okay, so it means that, okay, I call this cells to go, so it's not next cell anymore. So maybe I print out cells to go here. Okay, I have an error here. I put next cells here, it should be cells to go. Okay, so it looks like it's working. Yeah, pop from empty list again. So 4, 5. And then there's a 4, 5, nothing. Maybe we should just put that. Don't know whether this will hurt my code's performance. It's like it's the first time that I'm trying out something like that. Cannot unpack non-type object. Okay, remove key from dictionary. Okay, I guess we can pop the key. Okay. Okay, it looks good. Alright, there's a lot of goals right now. And most of the goals are involved to, okay, looks like it's doing well. So with these goals, it doesn't have the same behavior like crisscross again. It looks like it can just whack straight away. Yeah, I guess goals thing works, so keep track of the previous goal. I think this is done. Spawn smarter, maybe I'll do that in the next stream. It's been about 3 hours. Wow, I spent 3 hours doing this game today. Okay, so okay, what's wrong here? Okay, maybe it's too soon to remove the goal part. Looks to me like it's doing the left right again. Yeah, let's just take a look at this 5-5. Okay, 5-5. There's no go at 5-5. Okay, but where is 5-5 going to? Okay, I don't have a 5-5. Should have a 5-5 somewhere, right? Move. 25 to 112, 113, 114, 115, 116. All these are 115, 116. I think it's this one. Move. Oh, this is the number 5526. 55 is going to 26. Okay, yeah, I mean that's a legitimate move. And here, this one is 4-5 already. So I should look for move 4-4-5. Move 4-4-5-6-6. Moving back and forth. Yeah, so irritating. Yeah, so apparently this does not. Oh, okay, I know why. I did not update the goals, is it? Maybe this cells to go is not updated correctly. Cells to go should be here. Which is already here already. So I'm not too sure why this does not have a goal. Supposed to have a goal though. But its goal is like being moved left and right. Okay, so actually there's this 5-5. Is this 5-5 in this list of goals? Okay, over here there's a huge list of goals. Oh, I know why already. I know why already. We should have a new goals here also. Yeah, so over here at the end of it. Okay, then now make the goals the new goals. Copy a dictionary. Yeah, and copy the whole dictionary. Dot copy. Okay. Yeah, so because when I did my updating of the new goals, it affected the old goals. That's probably why it did not remember its goals after a while. So we just update this in the update. Yeah, it'll be so much easier if I have the ID of the units that I can keep track. Okay, over here you see over here something wrong here again, like he's doing limbo, up down up down up down. Yeah, so irritating. I mean, like, I'm sure there's some goals that are already set for it, but I'm not sure why it's not moving. Yeah, it's probably like going here already. Where is this thing going? Like, okay, let's just look at like this 17-7. Let's see where 17-7 is heading to. is going to 16.1. Okay, and how about this 17.6? 17.6 going to 17.6 is going to oops 17.6 is going to 18.8. Okay, so these goals are not reflected here at all, which is weird. Like, yeah, it's really very weird. I have a goal for it. Like 17.6 is supposed to go to like 18.8, right? It should actually pass by 77, 17, 18.7 and 18.8. All this should be in the the trajectory here that it's supposed to go. But somehow it's not following the trajectory. Like it's not even having a trajectory in this goals here. I don't know, did I reference wrongly? Oh, is this y because of xy here? So it should be yx, right? Isn't it? Yeah. It should be xy like that. Then here I just change to yx. So maybe it's because of that. That's why the goals did not it did not store the goal because like of this xy issue. Okay, looks like that's not the issue. Maybe I should make the goals as like yx. So here I find the squares, I find yx. I'm not sure, yeah, it's weird. $5.15 goes to 4.3. Yeah, it's very weird that it goes so far away. The goal is like going to 4.3. Oh, I know why. Because it's not updating it anymore already. It's going all the way there. But because I think after it crash into the opponent, the goal is not there anymore. So like it's not versatile enough. Like maybe we should only fix the goals like I don't know, artificially we should only fix the goals for 3 times. Yeah, maybe like F, turn num here. So we should just do remove all goals every 2 turns. So weird, yeah. I'm keep doing this kind of, yeah. If Okay, so that we don't get stuck there, because I think all of them want to go to the opponent territory, but that's not invalid sequence, not a function on line 12. Oh, okay. Yeah, wow. Someone is number 2 already. Someone is above the boss. Oh yes, Savita is above the boss. Congratulations to Savita. Okay, let's see. 120. Invalid. Oh, okay. It's here. Okay, looks like it's working, I guess. I mean, it's still doing this ding dong thing, but at least, I mean, after it resets the goals, like, I guess it's either heading here or here. So I think I need to, if there's a goal, I need to basically remove that from the, okay, so if goal cell is in the other one, which is in neutral squares. Yeah, we could do this. Remove this. So that we can like update the rest. I'm doing so well now until here. This is awesome. Yeah, I don't know what happened after this. This thing is, where is this thing going? 7-5 going to 7. 6-6-6-5. It's going to 7-5. Why is it going to 7-5? 5-7, you mean? 5-7. Yeah, yeah. Yeah, maybe we do it every 4 turns instead of every 2 turns, so that there's more continuity, I guess. Yeah, we don't get stuck up to our earlier goals, but we still want to fulfill it. Alright, okay, then this actually looks correct already. It's just a matter of us not winning the boss because of our code, but the goals thing is correct. Looks like this goals is kind of affecting myself. It's kind of affecting the performance of the algorithm. Let's just remove the goals altogether and see what happens. Yeah, without the goals is like more versatile. With the goals, actually it's like harming the agent. See, now it can win. Maybe we just need to remember, instead of having goals, we just need to remember where this unit came from in the previous time step, and then we just need to make sure that it doesn't go back there again. Yeah, because like the goals kind of seem to harm it. Yeah, so maybe instead of the goals, what we can do is like previous. We just want to make sure the thing doesn't U-turn. So unfortunately this goals thing is like kind of harmful. I don't know whether it will do better against other people, but against the boss it's definitely not like doing that great. But we can run it on the arena and see how it goes. Like, see now it's performing worse. We can just do on the arena and just see like whether this fares better against other people, because it did worse against the boss. I think it will do badly against other people also. I really don't know. Yeah, no, it's actually doing not too bad. Oh, it's actually not bad. Yeah. Oh, okay. So it didn't do too well against the boss, but this ghost thing has helped it to like expand more, I guess. I see over here it gets stuck also. Okay, so I think what I need to do is maybe like, maybe instead of going to the goal directly, keeping track the whole goal, just do not return to the previous square, because like that will be like quite bad for the agent. So maybe let's just play this code, make sure that it's running in the IDE. Okay, after that then I think I'll call it a day for today. I've been coding for 3.5 hours already. Wow, this took longer than expected. But yeah, see, it's not doing well for the boss anymore. Yeah, so maybe we don't have to track the whole goal, but instead just return to the previous square. Surprisingly, it's not doing well against the boss, but it's doing well against a lot of other people. Yeah, so who knows, maybe this goal thing is better against humans rather than that boss. I mean, the boss also came from a human player, I guess, one of the participants, but perhaps it's better for the league. Okay, if not, yeah, probably I'll stream this again next Saturday, or next, maybe one of the weekdays next week, and then we'll see whether we can get to Silver League or even Gold League. Okay, thanks for watching, and see ya. Signing off.